Now, in this problem, we are to calculate the pH of the resulting solution. Let's look at the question. If 25 cm cube of 0.160 mole per dm cube of potassium hydroxide is added to 50 cm cube of 0.100 mole per dm cube of HNO3 acid, what is the pH of the resulting solution? Now, this question is a combination of both the knowledge of neutralization reaction and pH of solutions. First, what is neutralization reaction? And how do we know it's a neutralization reaction? Okay, neutralization reaction is a reaction between an acid and a base to produce salt and water. Now we have a strong base, potassium hydroxide, and we have a strong acid here, which is nitric acid, HNO3 acid, with a basicity of 1. What's the meaning of basicity? Basicity is the number of replaceable hydrogen present in an acid, um, in one molecule of an acid. That's what we call basicity. So HNO3 here has a basicity of 1. So this reaction between an acid, a strong acid and a strong base in this case, will produce a salt and an acid upon complete neutralization. Okay, so now also, what is pH? pH is a measure of the degree of acidity or alkalinity of a substance. So let's take a deep dive into the concept of pH of a solution. As we have said, it's a measure of acidity or alkalinity of a substance. How do we calculate pH of a substance? Generally, pH is calculated as the negative logarithm of hydrogen concentration. So, um, let me bring in what we call the pH scale. So we have to understand the concept of pH very well. Now, the pH of 7, this is a pH scale. On the pH scale, the pH of 7 is regarded as the neutrality pH. So a substance that is neutral has a pH of 7. Okay? A pH that is less than 7 is acidic, while a pH that is greater than 7 is alkaline, or you say basic, it's alkaline, or you say it is what? It is basic. Now, how do we calculate the pH of a substance? How do we calculate the pH of a substance with known concentration? Okay, let's take this. So the pH of a substance is equals to negative logarithm of the concentration of hydrogen. And you could say the pOH is also the negative logarithm of the concentration of hydroxyl air. Okay? And technically the pH added to the pOH gives you 14. So in other words, you could calculate pH as 14 minus pOH. Okay? So this is very important. Now, having discussed the concepts around pH, another very important thing that we need to look at is the neutralization reaction. We know generally when an acid combines with a base, it produces a salt and water. Okay, that is, the hydrogen from an acid, let's say we have an acid Ha, for example, reacts with a base, let's say a base BOH. Okay, what happens? The proton here, the hydrogen plus, combines with the hydroxyl to form water molecule, and the um, cation here, the base of the base, combines with the anion of the acid to form the the salt. Okay, as I said earlier, the number of replaceable hydrogen present in an acid is, in 1 mole of an acid, is the basicity of the acid. So in this case, what we have is a reaction between nitric acid, hydrogen trioxynitrate 5, and potassium hydroxide. 1 mole of this suffices to neutralize 1 mole of potassium hydroxide. No, so good. Having explained that, now let's try to look at the question closely. The question says we have, let's write the reaction, equation of reaction. We have we have HNO3 combines with potassium hydroxide to produce potassium nitrate and water. And we could clearly see that this is a one-to-one reaction ratio. Why? Stoichiometric ratio. Because um, 1 mole of hydrogen trioxynitrate 5 is enough to neutralize 1 mole of potassium hydroxide. So, in any situation, in this ideal situation, where exactly same amount of moles of Na of the acid is supplied to react with the base, we are going to have a neutral solution. So this process is going to be neutralization. That is, the acid has completely neutralized the the base. So we were, now what is given? We have the volume of the base to be 25 cm cube, and its concentration to be 0.16 mole per dm cube. So meaning for the acid, for the base, we have 25 cm cube and with a concentration of 0.16, and for the acid we have 50 cm cube and a concentration of 0.1 mole per dm cube. Also, this one is mole per dm cube. Okay. Now, based on the fact that we have the volume of the acid and we have the concentration of the acid, also for the base, we have the volume of the base and the concentration of the base. We can calculate the number of moles, because number of moles in solution stoichiometry, number of mole is concentration multiplied by volume. Now let's calculate the number of moles of the acid. Number of moles of the acid is just a product of the volume of the acid and the concentration of the acid. So number of mole of the acid in this case is going to be 50 multiplied by 0.1, or let's just follow the convention. Concentration is 0.1 and the volume is 50, but it's in cm cube. We have to convert to dm cube by dividing by 1,000. Now we do the same thing for the base. The number of mole of the base here is going to be what? The concentration of the base multiplied by the volume of the base divided by 1,000, because our volume is expected to be in dm cube. So having done this, the number of mole of the acid will be obtained as 0.05 moles, while that of the base is 0.004 moles. Okay, so what does this tell us? It tells us that the number of moles of the acid is more than the number of moles of the base, since what is required is 1 to 1. So here you see that the base here is the limiting reagent. It is going to dictate the number of moles of the is going to dictate the number of moles of the acid that react, since it is provided in a limiting quantity. So the number of moles of the acid exceed the number of moles of the base by a difference of that 0.001. If you take the difference between this, we have that means excess acid of 0.001, a difference between this 0.001 moles. Okay, meaning that the resulting solution after you mix 50 cm cube of the acid and 25 cm cube of the base, of course you know that the total volume here, the total volume is going to be addition of this and addition of this, which will give us what? Which will give us um, total volume, total volume of total volume is 75 cm cube. 75 cm cube is the total volume after the entire solution. So with the number of moles, excess number of moles of acid known and the total volume known, we could calculate the the concentration of the acid that is in excess. So since the number of mole of acid that is in excess, number of mole of acid, let's say excess, is 0.001 mole, and the total volume, let's call it volume total, is 75 cm cube. We can calculate the concentration of the excess acid, concentration of excess acid, and that will be what? Number of mole divided by volume. So number of mole here is 0.001 and the volume here is 75. So we convert it to dmq by dividing by 1000. So we have 75 by 1000, and if we compute this, we are going to get 0.0133 mole per dm cube as the concentration of the excess acid. Now, HNO3 is a strong acid, and since HNO3 is a strong acid, it dissociates completely when dissolved in what? When dissolves in water. When dissolved in water. Meaning, and since because of the fact that the basicity of HNO3 is 1 mole, is 1, a mole of HNO3 is going to produce 1 mole of hydrogen ion. Hydrogen ion. So consequently, it implies that in this same solution, the concentration of hydrogen ion is going to be exactly the same as the concentration of the what? Of the HNO3 acid. Okay? This symbol is commonly used to represent concentration. So the concentration of the HNO3 will be exactly 0.0133 mole per dmq, or you say mole per liter. So from here now, since we know the concentration of the acid, we could then apply the formula. pH is the negative logarithm of the concentration of H plus. And what would that give you? Negative logarithm of 0.0133. If you punch your calculator, you will get approximately 1.88 as the concentration, as the pH of the solution. So looking at the question we have, that is option D. It means option D is the correct answer. Okay? So if you understand the solution, now try to use this your knowledge to solve these similar questions. Question 1, 2, 3, and 4. Try to use what we have learned in this particular lesson to attempt the following question, and let me know the answers in the comment section. Also, don't forget, you can share this video with your colleagues that are also preparing for similar exams, and don't forget to also like. So see you in the next video. So thank you very much.